Audible? Okay. Hello everyone. Am I audible?
Yes, sir.
Okay.
Yes, sir.
So yesterday we had discussed unit number 5 concept, matrix theory. How we can represent a graph by using the matrix. Clear? How we can draw the graph by using the matrix. Clear? So there are two types of graphs that we'll learn in this unit. One is the adjacency matrix, and second one is the incidence matrix. Okay, adjacency relation between vertex to vertex, and incidence relation between vertex to edge. Okay, so by using that two concepts, we can create two types of matrix: adjacency and incidence. Okay, and here the application of matrix is given. What is the importance of matrix theory in computer science? Okay, so that we discuss, and then after definition of adjacency, and then after we discuss matrix definition, which value we have to replace as a matrix output, okay, as a matrix value. So we'll replace this, we'll fill this matrix by two value, 1 and 0, okay. When we'll put 1, if the uh, connection between this two vertex, okay, if I and Z vertex are connected, then we'll put a 1. If there are no edge, then A to B connections will put a 1. There is no any edge, then we'll put a 0. Okay. So this is the definition of adjacency matrix, and then after one of this example we had discussed in the last lecture, how we can manage the order based on the graph. Okay. So that depends on number of vertices. Clear? Uh, okay. Then after mention the notations of given vertices clear as a column and as a row. Okay. And then after check uh, Okay, now am I audible?
Yes, sir.
Yes, sir.
Okay. So here we create this matrix based on the data. Clear? As per the relations, we can manage the 1 and 0. Okay, to the graph. Okay. And then after consider second vertex V2 and check its connections to the rest of all the vertices. And here we know that this matrix is symmetric matrix. Okay. So what does it mean? What is meaning of symmetric? A is equal to A transpose. Okay. And if we check the lower and upper triangle form, okay, that is diagonal, just remove it and then check upper value and lower value. So that will be the mirror image. Okay. That is meaning of a symmetric matrix. Lower and upper triangle matrix. That will be a same. So therefore it is known as a symmetric matrix. So we just observe the first row and then map this value to the first column. Then after find the second row and write this whole value to the second column. Okay. Then after third row and write this whole value to the third column. Clear? That way you can find the first answer. Clear? So that example we had discussed in the last lecture. Then after these observations we had discussed. Okay. Okay, if the graph contain any loop, without loop the diagonal entry will be 0, and if it contain any loop get, then this entry will map as a 1. Okay, AII entry means A11, A22, A33 entry will be a 1. Okay, and there is no any provision for parallel edges. Clear? If the graph contain parallel edges, then we cannot find the matrix for adjacency case. Okay, and third one, we can check the degree by using the matrix value. Clear? If the any vertex does not have any degree, then we can check the answer of the degree. Okay, check the answer of degree of that vertex by using the matrix data also. Okay, so for that we just check number of ones appear in the each column and each row. Okay, particular column and the row. Clear? We just check a particular row and column for the degree. So for the first row will map to the first vertex answer. Okay, second row will map to the second vertex. Third row will map to the third vertex and so on. So number of 1 appear in the first row, that is a 3 times of 1. So what will be the degree of first vertex? That is a 3. Okay. Number of 1 appear in the second row, that is also 3. So degree of the second vertex will be also a 3. Okay. And so on. Continue this process up to the last vertex. You can also use the column data. The number of 1 appear in the column. First column for the first vertex, second column for the second vertex. And so. So by using this, we can manage the degree. And then after we discuss this example, up to this we had discussed in the last lecture. Okay. Now let's add some more example. Yeah, this one. That is 6 vertices are given that here in this matrix, in this graph. Okay. And each of have degree 3. Clear? Each of the vertex has degree 3. So what will be the order of the matrix? That will be the 6 by 6. Clear? 6 edges and the 6 6 column and the 6 row. Clear? So without notation, you can also create this type of matrix. Clear? That's very easy. Without notation, I have not mentioned the notation here, but without notation, you can also create the true answer. Clear? If it is required, you can mention the notation to the row and to the column. It is A, B, C, D, E, F. Okay, and mention also the notations to the row also. Clear? In this way. If it is required, just use it. Okay. If it is not required, you can find direct answer also. Here mention A, that is B, C, D, E, and F. Okay. And here it is also A, B, C, D, E, and F. And now start the derive the value. So A is connected with which 3 vertex? That is a B, C, and F. Okay, A is connected with 3 vertex B, C, and F. So just replace the 1 first. Okay, here replace put a 1 first. It replace B, C, and F, and rest of entry will be 0. Okay, then after check second vertex B. That is incidence with A, B. B is incidence with A, E, and D. Clear? So replace there 1 and then rest of entry will be 0. Okay. Then after for third vertex C, so C is connected with A, then after D, and then after E. Clear? So C is connected with the A, then after D, and then after E. Clear? So at that entry will be 1 and remaining entry will be 0. Okay. Then after D is connected with B, C and F. So replace their 1 and rest of 3 entry will be 0. Okay. Then after for E is connected with C, B and F. So replace here 1 and rest of entry will be 0. Okay. Then after F is connected with A, D and E. Put a 1 and rest of entry will be 0. Okay. That will be your matrix. Clear? And you can verify also after that it is correct or not. Clear? So how we can verify that? How we can verify that? Here you can consider degree concept. Okay. Verify the degree. As we know that we can easily check the degree from the graph. Okay. The degree of all the vertex is a 3. So each and every column, each row and each column should contain the 3 times of 1. Okay. Each column and each row should contain the 3 times of 1. Clear? If there is less 1, otherwise greater than 3 times, okay, then it will be, it is a mistake you have to create in the solution. Clear? So that is the answer for this graph. Okay. Here there is no any loop is content. Clear? So here we can say that this diagonal has all the entries 0. Clear? Why it is 0? Because the graph content no any loop at any vertex. ठीक है? ग्राफ में कोई भी लूप नहीं है. Therefore, this diagonal entry will be 0. ठीक है? Suppose के at the place C, if there is a loop here, okay, so we'll consider the C entry. Okay, means here it will be the 1. Clear? If there is a loop at the vertex or D, clear? Then we'll consider D comma D entry. Means this entry will be a 1. Clear? Now there is no any loop it here, so it will be a 0. Okay. And there is a third example. That is which graph is here? ये कौन सा ग्राफ है? Peterson graph. Which graph? K5. Is it correct? K5. What is the definition of complete graph? Yes, what is the definition of complete graph? That you already done in the unit 1.
Between every two vertex there is a edge.
Every two vertex there is a edge. Is it correct? Every two vertex there is a edge. How we can explain another way? Each and every vertex should be connected by edge. Each and every vertex should be connected by edge. Each and every vertex should be connected by edge. Now apply this condition for all the any two pair. Each and every vertex should be connected by edge. Is it correct? Okay? Each and every vertex is connected by the edge. And how we can verify by another way? If it is a complete graph, okay, and it involves the 5 vertex, the degree of each and every vertex should be 4, means n minus 1. If it is a kn graph and if you to verify it is complete or not, so degree of each and every vertex should be n minus 1. So here it is a k5 graph, okay, k5 graph, and now you have to create it matrix. Okay? So 5 vertices that A, B, C, D, and E, and it is also considered 5 vertex. If it is required, you can mention the notation. Okay, but now it's very easy to derive the matrix. Clear? Each and every vertex are connected. Each and every vertex are connected except the itself. Okay, means if it is a loop here, then it is connected with itself. But now no any loop there. So all the diagonal entry will be 0 there, and remaining all are connected. Means A is connected to rest of 4 vertex. Okay, B is connected to rest of 4 vertex. C is connected to rest of 4 vertex. What does it mean? We just consider this diagonal as a 0. Okay, and remaining all the entry will be a 1. Clear? बाकी सब entry क्या आएगी वहां पे 1. Why it is 1 there? Because each and every vertex are connected. B A to B connected, A to C connected, A to D connected, and A to D connected. Clear? And same for the column. Now for second, B is connected with all other. That is C, D, E. Clear? C is connected with all other. Clear? D is connected with all other. And E is connected with all other. Clear? So that is your answer. Each and every vertex connected means in every complete graph you will get this type of answer in matrix. Clear? Except the diagonal, in any place no any zero. Okay, except the diagonal. उसमें सब zero आएगा, बाकी सब place पे that will be a 1. Clear? That will be a 1. So that is third example. That is the answer. Okay, and then after fourth one, yeah, all of you try this one. Then we'll check it answer. All of you derived matrix. That is 5 vertices are given. Our lecture time is 10 o'clock. Okay, those who are joined late, okay, after 20 to 24 minutes, please leave the meeting right now. Okay, good. So you done it? Okay, it's very easy, that not a difficult. Okay, to create a matrix from any graph. It's limited number of vertex right now, 5 vertex only with some edges. So first consider 5 by 5 matrix. Okay, keep the notation if it is required here, A, B, C, D, E, and here it also mention A, B, C, D, and E. Here, and then after fill the entry in this box. Clear? Yeah, good. So that is A is incidence with DEB. Okay, एक इसके साथ connected है, एक D के साथ, E के साथ और B के साथ. Okay, so replace that one. That is a B, D, and E. Okay, and rest of entry will be 0. Means 2 entry will be 0. Okay. Then after B is connected with C, E, and A. So that is C, A. Let's put here also the same value 1, 0, 1, 1. Okay. Now B is connect, here it is 0. It connect with the C also, A also, and E also. So that is 0. Now consider this row as the second column. So it is 0, 1, 1, 0, 1. Okay. Then after third row it for C. So C is connect with the D and B. So that is here D, and rest of entry will be 0. Okay. And here put 1 and 0. And then after D is connect with D to D. Okay. Means it is 1 here at the loop, and rest is 1, that is at the place E. Clear? Here it is also 1. And now for E to E, that you have to put 1. Clear? That will be your matrix. Okay? This answer you will get in case. Here first row will be 0, 1, 0, 1, 1. Second row is 1, 0, 1, 1, 0. Third row will be 0, 1, 0, 0, 0, 1, 0. Fourth it is 1, 0, 1, 1, 1. And last is 1, 1, 0, 1, 1. Okay? The answer you will get. And same for this graph, we'll get the solution. Clear? 5 vertex are there. Clear? 5 by 5 matrix you will get. And at the place E, there is one loop that. So E comma E, okay, E to E will be 1. And remaining diagonal entry will be 0. Clear? And then after you can verify this answer by observing number of 1 appear in the first row, second row, third row, fourth, and so on. Okay? So these are the one way. Okay, we have one graph that, and we can create a matrix by using the graph data, by using the adjacent relation which mentioned in the graph. And now we'll apply the reverse case. If your matrix is that, okay, one of the data of matrix we have, now you have to create it graph. ठीक है, अब कोई मैट्रिक्स आपके पास है, उसका आपको ग्राफ बनाना है. ठीक है, so how we can create the graph, which data is required to create such a graph. So let us consider one of the matrix here. The matrix is given that, okay. So first case is how many vertex we can include in our graph. Okay, that is the first question, because we cannot consider any random graph with any number of vertex. As per the data of matrix, we'll create a graph. Okay. So first check the order of this matrix. Here order of the matrix is a 4 by 4. Okay. First step to create a graph by using the matrix. First check the order of this matrix. So order of the matrix is a 4 by 4. So what does it mean? How many vertex the graph will contain? Of 4. Okay. Because if any graph contain 4 vertex, then we'll get a 4 by 4 matrix. Now the matrix is given here. If order is a 4, that 4 cross 4. So the graph contain a 4 vertex. Okay? And you can mention any notations to the vertex. Okay? Notation is not mentioned here. You have to put A, B, C, D, E, and so on. You can put any notations to the vertex. Okay? So next step में आपको कोई भी पोजीशन में 4 vertex प्लेस करना है. ठीक है? That is the next step. That is a A, it is a B, C, and D. Clear? A, B, C, D. And for remove the error and so on, okay? You can also mention the notation here, which notations we have used in the graph. Okay? These are the notations to the matrix, clear, which we have used to the graph. So now we'll connect it, okay, as per the data of matrix. Clear? As per the data of matrix. So here first we'll consider the first vertex and we'll identify connections with other vertex. So A to A entry 0 hai. What does it mean? There is no any loop at the place A. Okay? A and B entry 1 hai. Okay, A to B is 1 there. So what does it mean? A and B is connected by the A. Okay? A or B ko aapko connect karna. Then A and C is also 1. So connect A and C by the A. Okay? And A to D is also 1. So connect A and D by the A. Okay, that is step 1. Consider first row and check it connection with rest of all. Okay? So if A to A is 1, then create a loop at the place A. Then after consider second vertex, A to B is 1 also, A to C is also 1, and A and D is also 1. So connect it by the A. Okay? And now from second row, so B to A is all 1 here. So we will not create again edge from B to A. It already created. Okay? It already created that. So we cannot create another edge from B to A. Now B to B is a 1. So what does it mean? We will create one loop at the vertex B. Okay? We'll create one loop at the vertex B. Clear? Now B to C is 0 means there is no any edge between B and C. And B to D is a 1. So create edge between B and D. Okay? Create a edge between B and D. And then after C with rest of all. So C to A is already connected. Okay? C to B there is no any edge. C to C there is no any loop. And C to D, this will connect C and D. Okay. And now for D is already connected. D to A is connected. D to B is connected. And D to C is connected. So you will get this type of graph. Okay. First, we'll observe the matrix data. Okay. And no, question is also mentioned that you have to derive the edges by using the following adjacency matrix. Following adjacency matrix. Okay. Incidence. For adjacency matrix, we'll consider the order that is equal to the number of vertex. Okay. So order of the matrix that is equal to 4 here. So number of vertex the graph will contain that is also equal to 4. So place the 4 vertex in any position. Okay. You will get different type of shape if I change the position. Clear? If I change the position of A, B, C, D, you will get different shape. Clear? So कोई भी position आप उसको place कर सकते हो and then after start the connecting it and fix the first row first. Use the first row, then after second row, third row, and so on. Clear? So first row is for the first vertex, and then after check its value with the rest of all vertex. If it is a 1, then make one edge between these two vertex. If there is 0, then there is no any connection. Okay? And do it for second vertex, third vertex, and fourth vertex. Clear? And keep one things in mind. Okay? Here we consider A to B connection by the edge. So here it will be repeated here. B to A connection. So for B to A will not create another edge. Okay. Same for C to A. So C to A connections will not create another edge between C and A. Clear? A to C is same as a C to A. Okay. A to C is same as a C to A. That is both are equal. So is it clear to all to create a graph by using matrix? Okay. Let's that is solution. Okay. That is solutions for this one, and we'll get same. Okay. I just rotate this, change the place of A, B, C, D. So that is answer. And then after second one, what is the order of the matrix? 6 by 6. Okay. So how many will contain? 6 vertex. Okay. So place 6 vertex in any form. Okay. And then after start the connecting. Notation is mentioned here A, B, C, D, E, F. So use these notations. That is A, B, C, D, E, and F. Okay. This A, B, C, D, E, F. If you change the position of the vertex, you will get different shape. Okay, but it's also true. ठीक है, अगर आप vertex की position change कर देते हो, तो graph different हो जाएगा, but that is correct also. ठीक है? Now A is connected with the B. A to A is 0. That A is connected with the B. A to C is 0. A to D is 0. A to E is connected. So make one edge between A to E, and then after A to F. Clear? These are the 3 edges from the clear. Now for the second vertex B. So B to A is already connected. Now B to C that we have to create, and B to F that will create. B to F. Okay. That is for second row. Clear? How many edges we have created? 3 edges. Clear? Because there are 3 times of 1. Okay. And then after for third vertex C. So C is connected with the B first. So C to B is already connected. C to D that you have to create, and C to F. C to E that will create. Okay. So these are the 3 edges from the third vertex C. Okay. And there are 3 times of 1 is exist to the third row as well as third column. And then after fourth vertex D. So D to C is already connected, and D to F that you have to create. So connect D and F here by the edge. How many edges we have created from the D? 2 edges, because there are 2 times of 1 appear in the fourth row. Okay. And then after E with rest of all. So E with A is connected, and E with C is already connected. So there is no any edge need to create again. Okay, from the vertex E. And now from F. So F to A is connected, F to B is connected, and F to D is connected, and rest of all entry are 0. So this is your graph for this data. Okay. There is no any loop at any place. Okay, because diagonal entry are 0. Okay. So it is a graph without any loop, without any parallel edges. Okay. and then after you can verify the degree also, okay, as per the number of one appear in the each row and each column, and map this value to the particular vertex. ठीक है? If you change the position, you will get different shape. ठीक है? उसका design थोड़ा बदल जाएगा, but that will be also correct. Okay? So that is answer of this one. If it is required, just take a screenshot. Okay. If you need to verify that, you can take the screenshot. And now for third example, I just remove it. Okay. To display the third example. Yeah. That is content of 5 cross 5. Okay. The order of the matrix is 5 cross 5. So what will be the answer? That is a 5 vertex. The graph will contain. Okay. Consider any 5 vertex in any form. That is A, B, C, D, and E. Okay? And then after start the connecting. So A to B is a 1. A to C, that is also 1. And A to D is also 1. Okay? B with rest of all. So B to A, that is already connected. B to D, that you have to connect. And B to E, that you will connect. Now C with rest of all. So C to A, that is already connected to connect. And then after D with rest of all. D to A, B, and then after D to D, D to C is connected. D to D means a loop, and D to E, that is connected. Okay, and then after E with rest of all, so that we have this part. Clear? So that is answer of this one. Okay, and we can also use this tool to derive the matrix. Clear? For any graph. Let's check this how we can use this option to verify your answer. Okay, first you have to create graph, okay, as per the given data. Five vertex I have considered, and now let's connect it. कोई भी ग्राफ जो भी आपके पास है, you can create it, okay, and then after okay, that is the graph I have, arbitrary कोई भी एक्सेप्ट बना, ठीक है, and then after use these options to derive the adjacency matrix. Okay, two options are given there, adjacency matrix, and we'll get the answer in this way. Clear? That is your answer of the matrix data. Clear? So the setup is matrix using the comma. Okay, that is comma means next value. Clear? That is given here. You can verify that A is connect with the B, C, and D. So it is connect with the B, C, and D. The rest of two entry are 0. Okay. Then after B is connect with the A, E, and D. So it is A, E, and D. Clear? That is for second row, third row, fourth row, and so on. So you can verify your answer. If you have any doubt in your answer, And by using that you can verify it. उसके लिए पहले आपको जो भी ग्राफ है यहाँ पे ड्रॉ करना है, ठीक है, and then after use this command to derive it, ठीक है, to find out. And you can modify also the graph. Okay, let's consider one of the loop here at any vertex, ठीक है, loop at every vertex. Let us take and let's consider this graph. Okay, so here you can observe that diagonal entry let place a 1. Okay, A2 entry is 1. Then after B2B is 0 because there is no any loop. Okay, then after C2C is 1, D2D is 1, and E2E is also 1. Is it clear? Okay, so these are the solution of this both matrix. Okay, that is also mentioned here for your reference. Okay. So is there any confusion to create adjacency matrix, adjacency to graph and graph? Is there any doubt to anyone? Okay. So in the questions, for example, in mid exam as well as in final exam, definition is also important. Okay, so 4 to 6 mark questions we can create such as that define the adjacency matrix. Okay, and derive the adjacency matrix for K5. Okay, derive the adjacency matrix for K5. Derive the adjacency matrix for K23. So first you have to know what is the definition. You have to mention it for 2 mark. Okay, and then after you to also know what is the shape of K5. Because without graph you cannot create a matrix. Okay, so K5 notation is also not graph will be there. Clear? Sometimes graph also mention that draw the derive the matrix for this graph. Clear? But for any standard graph, we mention just notation only. Clear? We'll mention just notation only. So what is the particular notation for the standard graph? Complete bipartite graph. These are the standard graph we have. So we'll use the notations for creating any question. Okay, define the definition and then derive the matrix for K10, derive the matrix for K25, okay, derive the matrix for K, 2. Okay, that's it. And yesterday I forgot to announce for our CSC part. Okay, we have finished the unit 1 in the last lecture. Okay, so we'll arrange one short quiz. Okay, means MCQ quiz for a CSC component. Okay, 10 questions will be there, and we'll arrange this quiz in lecture session. Clear? Any of the lecture in next week. Clear? So you have 1 week time to prepare it. Okay, unit 1. MCQ type questions will be there. Okay, and you'll get 30 to 40 minutes to finish it during the lecture session. Clear? So in which lecture we'll arrange this quiz next week? कोई भी.
सर मीन्स 20 30 मीन्स कितने MCQ होंगे?
10 MCQ.
ओके सर, ओके.
10 MCQ will be there as per the our concept. ठीक है, जो भी आपने पढ़ा है, ठीक है, in this unit 1. Okay, so next Tuesday. Okay, so in the next week, this day, okay, means next Tuesday we'll arrange this quiz in this lecture session. Okay, during the lecture session. In Google Form online. Okay, you can also access the mobile during this lecture session. Okay. Now next definition is that incidence matrix. Okay. So what is meaning of incidence relation? Adjacent relation means it is a relation between vertex to vertex. If they are direct edge between these two vertex, then these two vertex are known as a in adjacent relation. Okay. Now, what is meaning of incidence relation? First, we'll check it, and then after we'll use this definition. If you consider any of the graph, okay, let us consider one of the simple graph, which include the four vertex and three edges. It is E1, that is vertex A, B, C, and D. Okay, that is E2 edge and that is E3 edge. Clear? So here we'll consider relation between vertex to edge. So that relation is called the incidence relation. Okay. So A is connected with the E1. ठीक है, A E1 के साथ connected है, तो A and E1 are called incidence relation. Okay. A and E2 is also connected, so that is called incidence relation. Okay. A and E3 is also connected, so A and E3 are known as the incidence relation. Clear? But vertex D and E3, okay, vertex D and E3, E3H, that is not incidence. Clear? Because there is no any direct connection between vertex D and E3. E3H and vertex D. Okay? E3H means this one, that is in between A to B, and here it is vertex D. So there is no any connection between E3 and D. So E3 and D are not incidence relation. Okay? Similarly, for C and E3, it is also not incidence relation. C and E1, that is also not incidence relation. Okay? B and E1, that is also not an incidence relation. If they are direct connected, okay, from this vertex, any edge is connected directly from this vertex, then they are an incidence relation. If there is no any connection, then it is not a incidence relation. Okay. So how we can create incidence matrix, okay, for any graph. So what is the definition of that? Okay, let G be the graph with m vertices n edges. Okay, any of the graph with m vertices and n edges, and no self loop. Okay, no self loop, because we are using the relation between vertex to edge, vertex with edge. So here we'll skip the self loop from the graph. Okay, we cannot create incidence matrix for a self loop. Okay? So where matrix is denoted as a Aij for the size m cross n. M means number of vertex, n means number of edges. So what will be the order of matrix? That is m by n. Clear? If the graph contains of 4 vertex and 3 edges, so what will be the size of the matrix? 4 by 3. Okay? Size of the matrix will be of 4 by 3. 4 means number of vertex and 3 means number of edges. Clear? So पहले आपको vertex check करने हैं. Check the number of vertex from the graph. It will be considered as a number of row. Okay? And then after check number of edges from the graph, it will treat as a number of column. Okay? Vertex will treat as a number of row and edges will consider as a number of column. Clear? So that is m by n, that is order, where m corresponding to m vertices and n column and n column. Okay? Corresponding to n edges as follows. M means number of vertices, m means n row, and n means n column, means n edges. So the element of A, that R, is equal to Aij, and we have to put 1 if the particular vertex is incidence with a jth edge. Okay, means ith vertex is incidence with the jth edge. Here means A E1. So A E1 is incidence. So A to E1 relation will put 1. Okay. A to E2 relations will put 1. A to E3 relation will put 1. Clear? Let's create the matrix of this graph so we'll get exact idea what does it mean. And then after we'll discuss remaining example in next lecture. The order of the matrix will be 4 by 3. Okay. Mention the 4 vertex here, A, B, C, and D. Clear? And mention the 3 edges as a column. E1 means first column, for E2 means second column, and for E3 is a third column. Clear? Edge is treated as a column and vertex treated as a row. So 4 vertex means a 4 row and 3 edges means 3 column. Clear? So now we'll check A to E1 relation. Okay? A with relation between all the 3 edges. So A to E1 is connected by the direct edge. So here we'll put a 1. A is E2 is also connected. We'll put a 1. A to E3 is also connected. So here we'll put a 1. Clear? Now for second vertex and check it relations with all the edges. Clear? Second vertex is a B. So B is connected with E1. There is not any connection between B and E1. So here we'll put a 0. Okay? B to E2. There is no any connection with B and E2, so we'll put a 0. B2, E3. B and E3 are connected, they are incidence, so here we'll put a 1. Clear? Then after for a third row, for a third vertex, so C with E1 is not connected, C with E2 is connected, so it is 0, 1, and C with E3, that is also not connected, so it is 0. Okay? And then for a last row, for last vertex D. So D is incidence with E1 only, and rest of two edges are 0. So here it is put 0, that is a 1, 1, 0, and 0. Okay. So ith vertex means A is a vertex and it is incidence with E1, E2, and E3, then put 1. If it is not incidence, then put a 0. Same for second vertex, third vertex, and so on. Clear? So this type of matrix is known as a incidence matrix. Clear? Here we observe the relation between vertex with A. Clear? Adjacency means vertex with vertex. So it will be always a square matrix. Clear? Number of row is same as the number of columns. So it is a square matrix always. Here it is not the same always. Clear? Number of vertex is not equal to always number of edges. So here it is not always a square matrix. Clear? Right now this is not a square matrix. 4 row and 3 columns. So it is not a square matrix. Clear? But adjacency matrix is always a square matrix. Therefore it is symmetric matrix. Clear? So here it is not any condition we can use that it is always symmetric or not, because it is not always a square matrix. Clear? So here we'll keep up to this next lecture, and then after we'll discuss some more example for this definition.